Hi, everybody. I'm Timothy Mitchell with Mimaki, and it's a great honor for me today to have Steve Aranoff with you, or with us, with me. Steve is coming in live from Hawaii, actually, and through the magic of technology, we're able to communicate and speak to one another about a product on the finishing side that we will have at our Mimaki Digital Textile Microfactory event. And this, for me, is one of the more interesting and innovative products I've seen in a long time. Naturally, it kind of comes from the very fertile and productive mind of Steen Mikkelsen. And so Steve and Steen have put together a product which, well, I'll let Steve explain it, but it solves a major finishing problem. Because after you've gone through all your color work and you've done your file and you've sent it to the printer and you've printed to the fabric and you've transferred to a calendered press, now you have to do something with it. You have to ideally cut it, and then you have to finish it. You have to sew it. And go ahead, Steve, introduce yourself and explain to the nice people what you guys have built. And I don't want to give too much away because I want them to come to the event and see this really cool product.
Yeah, it's an interesting thing that back in the 1999 2000 timeframe, Steen was working with flatbed cutters in the traffic business to make signs for various DOTs, and he came up with the idea of adding a camera to a flatbed cutter, and out of that idea, something called iCut was born. And when we sold the company, which was called Mikkelsen Graphic Engineering, to Kongsberg in 2008, we had 20 OEMs using this software, which was automating the cutting of printed wide format material for the first time. And our next company, we sold to Gerber in 2018, and that company pioneered the idea of getting both laser cutting and traditional knife cutting on a typical flatbed cutting platform, and nobody else had done that at that point in time. We had a patent pending conveyor belt, which allowed the metal surface that you needed for laser cutting, which could be easily just unzipped and taken off the table quickly so that you could then go do router cutting or knife cutting. So we had a 3-year non-compete after selling to Gerber, and Steen's fertile mind, as Timothy mentioned, started thinking about, what else is there in the world that we could use a flatbed cutter for that would improve the automation of something to do with printing. And he came up with the idea that textile printing is a growing market, and nobody has yet figured out how to automatically sew multi-layers of textiles of any shape without resorting to a frame and, to some extent, semi-automatic or fully manual sewing. So he came up with the idea of diverting the conveyor, which would open up a small space while the conveyor still could work fully in the X direction of the table. And then in the space in the Y direction, he put another belt that has a hole in it, and in that hole goes a needle. And so if you have a traditional sewing machine in which you need a needle from the top and a bobbin from the bottom, you now have a way of sewing using a completely not normal, but fairly typical flatbed table that we're all used to in the printing industry. And so now, lo and behold, we can roll off 2 or 3 layers and maybe more from rolls of textiles, and we can hold them on the table only right where we're actually doing the sewing and cutting, so that we've got enough vacuum, which is also a patent pending concept, and we can now sew basically any pattern that we can cut traditionally with a flatbed cutting table. And so we can sew accurately, and then because we know exactly where we've just sewn, with a fairly small spacing, we can now laser cut or even knife cut the pieces and have fully completed pieces coming off the table. An interesting phenomena is that most of our traditional graphic suppliers, have trouble finding and training sewers. And one of the things that they're really having the most trouble with is sewing the SEG CATA strips onto the textile, which is going to be stretched into an aluminum frame. And we now have working a SATA distributing model, which is allowing us to do rectangular or square sewing of SEG strips onto the textile and automatically cutting exactly where you need them to put into the frame. One of the more interesting and hardest things for people to accomplish today is opening up a square or a rectangle in the center of an otherwise printed fabric display and putting a monitor in there. And this makes it really easy to do that accurately enough so that everything fits perfectly, almost untouched by human hands. And, we can move from there to other things that traditional printers do, pillowcases, security screens, flags and banners, table throws. All of these can be done accurately with sewing close to the edges and laser cut so that there's no need to hemming. And they basically will stand up to wind and sun in an outdoor environment as well as in an indoor environment. So we believe that enough traditional work being done by printers is capable of being accomplished on these systems. And there's lots more that they can accomplish, which we'll be happy to go through with you at the Mimaki event.
You know what my first question is? Are you taking investors?
Yeah, as a matter of fact.
You just listed about 10 things that are known distinct bottlenecks in the whole digital printing and finishing workflow. And sewing has long been one of the bottlenecks, is finding sewers, finding skilled sewers, training people to sew. And I think the companies that have been very successful in this market, two come to mind, which will both be at the event, Matic and Miller, is how do you automate SEG sewing to make it as easy as possible so you can have production people, not sewers, but just, the guys that do the welding and everything else in this shop. How can you train them to do a conveyor SEG system? And then your response is, oh, not only can we do that, we can cut it, we can sew it, we can put the SEG on, and it all is automated through a computer, basically, is software's running the whole thing.
And the interesting thing is that somewhere around 40% of the cost of the work being done is movement of material between cutting and sewing today.
Sure.
So we eliminate all of that. And we basically believe that the same ROI for these systems as we've seen in flatbed cutters, which are now sold in the thousands into our industry every year.
Right.
We're going to replace 8 to 10 sewers, manual sewers, with one computer operator. Now, we're going to have a sewing expert responsible for, worrying about things like tension and whatnot. And the next version of our system is going to have fully computerized capability. So every function of the sewing machine will be computer controlled going forward. And so we'll be able to get as many of these set up so that an operator can handle them without having to be a sewing machine expert.
Wow. And, I have a high degree of confidence, of course, in Mr. Mikkelsen's knowledge of operational flatbeds. I was one of the earliest adopters to the MCT lasers and used that for all of my samples for many years for all fabric because it did such a nice job. It was such a beautiful finish and everything else. I think you have a remarkable product. I'm proud to be one of the first places to really introduce it, in a public setting. I know you were at we were at Printing United, but I'm very excited that people will see this. And I was going to bring a video and everything, and I thought, you know what, I I want them to come and see the video and have the pictures and the explanations. Obviously, we won't have one physically, the whole thing in the facility in Los Angeles, but we will have, you will be there, and we will have a lot of visual assistance to walk you through all the steps so you can see what's being done here. Because I think the sewing was the big and remains the big bottleneck in automation for printing, for example, in the United States, is where do you find sewers? Where are you going to find people to sew all this? And I think you've made a huge stride technologically in that gap. And I have to say I'm very eager to see a lot of this work myself. So
Thank you, Timothy.
yeah, absolutely.
It's also interesting that the U.S. and Western Europe are certainly our initial markets for this. But if you look at some recent Boston Consulting Group data, it shows that labor costs in China are now approaching 80% of labor cost in the United States for the printing industry. When you look at how much it costs them to train and how much waste they have because of the poor training and people leaving and so forth. So, we're really at a point where on a worldwide basis, this kind of technology is going to make sense. And that's good news for both Mimaki and for Fastsewn.
Absolutely, it is. Look, on that note, I think we're going to call it an afternoon. I want to thank you so much for joining me from, are you on the Big Island?
I am.
Okay, I want to thank you very much for joining me on the Big Island. We didn't have any technological glitches, a little minor bump here and there, but looking forward to seeing you on the 30th of October. It starts at 9 o'clock. The first event goes off at 10. We'll have a very nice lunch. You'll have plenty of an opportunity to speak to Steve and ask him all the questions you want. And please come and see some of the new technology that we're going to be presenting and unveiling at our event. It'll definitely be worth your while. So have a nice afternoon, Steve, and go out in that beautiful, lush, perfect climate and enjoy yourself.
Thank you very much for inviting us to the event, and we're looking forward to seeing you and all of the attendees.
All right. Take care.
Bye-bye.